two terms are dominating every AI engineering conversation right now: context engineering and the AI harness, and almost everyone is confusing them. Teams spend weeks debating which one matters more. Builders copy system prompts from Twitter and call it context engineering. Others bolt on LangChain and call it a harness. Both are wrong. The confusion is expensive. Teams optimize the wrong layer, ship brittle agents, and then wonder why better prompts did not fix their broken execution. By the end of this video, you will have a precise mental model for both. You will know exactly what each one covers, where one ends and the other begins, and how to use them together. Let us start with context engineering. Andrej Karpathy coined this term. His definition, context engineering, is the art and science of filling the context window with exactly the right information at the right time. Before you can engineer context, you need to understand what the context window actually is. It is the only thing an AI model can see. Everything you want the model to know must live inside it. 4 things live inside the context window. The system prompt sets behavior and identity. Conversation history shows what was said. Tool results bring in real-world data. And injected documents give background knowledge. Context engineering is the discipline of deciding what goes in each layer, what to leave out, how to structure it, and in what order. It is not just writing a system prompt. That is one line in a much bigger design. Here is proof context engineering matters more than model choice. Take the exact same model. Give it a vague prompt versus a precisely engineered context. The outputs are not even close. The key insight, context engineering, is purely about the input to the model. It is the information design layer. It does not touch execution, tools, loops, memory persistence, or infrastructure. That is a completely separate concern. Now let us talk about the AI harness. The harness is a completely different layer. If context engineering controls what the model sees, the harness controls everything that happens around the model. The harness is the execution environment. It is the infrastructure layer that manages the agent loop, executes tools, handles retries, manages memory across turns, enforces permissions, and routes outputs. Think of the harness as the body that wraps around the model's brain. The brain can reason. The harness makes it act. Without a harness, the model was just a very expensive text completer. You have already used harnesses. Claude Code is a harness. LongGraph is a harness. The Anthropic Agents SDK is a harness. Every framework that wraps a model and manages its execution is, by definition, a harness. A harness is defined by 5 properties. It runs a loop, it has a tool execution layer, it manages state between steps, it enforces policies, and it decides when the agent is done. Now the critical distinction. These 2 layers solve completely different problems. Context engineering is a design problem. The harness is an engineering problem. Put it another way, context engineering asks, what should the model know? The harness asks, what should the system do? One is about information, the other is about execution. Here is the analogy that makes it stick. Context engineering is the recipe. The harness is the kitchen. The recipe tells you what ingredients to use and in what order. The kitchen is the environment, the tools, the heat, and the process that actually cooks the food. This matters because fixing the wrong layer wastes everything. If your agent gives inconsistent outputs, that is probably a context problem. If your agent crashes, loops, or ignores tool results, that is a harness problem. They have completely different symptoms. Now, here is what most people miss. These are not competing approaches. They are complementary layers of the same system, and you need both to be excellent. Great context in a broken harness means the model knows exactly what to do, but the execution environment fails to carry it out. The output is brilliant, but the system is unreliable. And a great harness with weak context means the system executes perfectly but produces the wrong thing consistently. Every tool call works, every result is returned, the output is just reliably bad. The winning combination is both layers built to a high standard. Engineered context that gives the model precisely what it needs. A robust harness that executes reliably, recovers from failure, and keeps state intact. Let us make the mental model concrete. When you sit down to build an AI agent, run 2 separate checklists, one for context, one for the harness. The context checklist. Is the system prompt tight, specific, and role appropriate? Is the right data retrieved and injected? Are there few-shot examples for the hard cases? Is irrelevant context stripped out to protect the token budget? The harness checklist. Is the agent loop bounded with a stop condition? Are tool results correctly injected back into context? Is there retry and fallback logic? Is state persisted across steps? Are permissions enforced? The clearest summary you can take away. Context engineering tells the model what to think about. The AI harness decides what the system actually does. Both are required, neither is optional, neither replaces the other. The builders winning right now are not better at prompting. They are not using a smarter model. They are building both layers with equal rigor. Engineered context, robust harness, that is the full stack. Next time you hit a problem with an AI agent, the first question to ask is this a context problem or a harness problem? That single diagnostic question will save you days of debugging the wrong layer. That is the full picture: context engineering versus the AI harness. 2 layers, 2 disciplines, 1 complete AI system. If this helped, share it with someone building agents right now. See you in the next one. Let us go deeper. Because context engineering is not one move, it is 4 distinct design decisions that compound on each other. Most teams only make one of them consciously. Decision 1. The system prompt. This is not a blurb. It is a contract between you and the model. It defines the model's role, persona, rules, output format, and reasoning style. A weak system prompt is a weak agent. Decision 2. RAG and retrieve knowledge. Retrieval is not just a search problem, it is a context engineering problem. What you retrieve, how much of it, and where you place it in the context window all determine quality. Decision 3. Tool schemas as context. When you give a model a tool, the schema you